Okay. All right. Outline today. Real quick, we're going to practice drawing and measuring angles today. The big thing that in our topic here, we're in the 4th section. Okay, we're talking about angles and angle measure. These are our topics we're talking about. The big thing we have to start with today, I said there were parts of an angle we haven't discussed yet. We need to discuss standard position. This is a way that guarantees everyone in this room will draw the exact same picture. Standard position. Guaranteed. Everyone has to draw it the same way or it's counted wrong. There's a couple different parts we're going to discuss. One of the parts is called the initial side. Then we have a vertex. And then we have a terminal side. These are the parts we need to discuss today that you know how to do it. Once we have this and we're drawing, and you guys get comfortable with what we're doing and how we're sketching, so everyone in this room will draw the exact same picture, then we're going to start measuring angles. So the measurement, using the protractor. The big thing here is that you gotta have your protractor out. You need it. If you don't have it, you can't be afraid. You gotta say it right now. We need to get you one. Because we have to be insanely accurate. I'm very picky on the way that we draw. It has to be within 1 degree to be counted right. It has to be insanely accurate. That's what we're gonna do. If we get a little bit of time today, I don't think we will today, but we'll have to do it tomorrow. We're going to do 2 more constructions today. Constructions are the things where we use compasses and straight edges. The one we're doing today talks about angles. We've done segments, right? We can copy a segment to a new location, brand new location. We're going to talk about how to copy an angle to a new location. That's what we're going to discuss. So we're going to try to get to that today. Now, I don't know if we'll get to both of them. We'll probably get to one. But that's what we're going to get to, and we have to discuss. Okay, questions, comments about what we're going to try to go to? Perfect. Okay. Now, first thing I'm going to have, if you have your graph paper, your grid, your graphs that you had the other day, take that out. You need your graph paper. I handed those out last Thursday and Friday. I want you to have at least one. You need those out right in front of you. Out.
It's crazy. I don't want to play Monday. Or Friday. I don't want to play Friday. Guess what this drawing is? What?
Because I need to set up me. I have 2 empty ones. In case my, I forget 2.
Don't lose none. That's the point you need to turn in what we did. That's the problem. Alright, graph paper, need it out. Okay, we should be on the 3rd graph, maybe even the 4th now. I think it's 3rd. 3rd. Right, all the drawings we've done. Alright, now the reason I bring this up. This is going to explain the quadrant system. Because on your graph, so if you're on your 3rd graph now, or 2nd graph, I don't know which one you're on, we have the quadrant systems. 1, 2, 3, and 4. And the question I always get is, why do they go in that order? Everyone always gets them wrong because they always think it goes clockwise when it actually goes counterclockwise. But the question is, why do they do that? It's because of drawing angles. This explains why it goes 1, 2, 3, and goes counterclockwise. So on your graph, take your pencil, and we're going to draw a dot right on the origin, right on the center. Put a dot. And we're going to draw a ray going along the x-axis to your right, going this direction towards the x. Just put it right along the x-axis, like so. Now the reason why I do that, you can put an arrow. That's our first ray. That is called the initial ray. In fact, I'm going to write that over here. That is the initial side, or initial ray. It's your starting point.
I was gone. I didn't get any paper.
done for both Thursday and Friday. Now you're missing like 3 graphs. All right, so your initial side. So once you've drawn it that direction, we're going to start there and we're going to open up counterclockwise. So if they ever say positive angles, like 30 degrees, 40 degrees, 50 degrees, you're going to be opening up this direction. You don't need to draw that little arrow, but you're going up, and now we're going to put a ray going off of that vertex again, but it's going to be in that first quadrant. Because when you open up, you always open up counterclockwise. This is the angle that's in question. This is my angle. Now, this is the point where this explains why the quadrants work the way that they do, why they number that 1, why they number 2. Because you always open up counterclockwise throughout the angle. You have your initial side, imagine that's like ground level. You're going to open up, the cannon going upwards, that's your angle. If you float it backwards, now you're at a negative angle. Or not negative, but it could be a negative angle, but it's just opening up further and further till you're facing basically behind you, basically, right? So, as it opens up, you'll eventually, if I kept opening, will be eventually facing like this direction, you'll be facing behind you. Because what type of angle is that?
Obtuse.
Obtuse, it's big, it's bigger than, it's bigger than 90. So eventually you'll be facing backwards, right? It's obtuse. That's why it's quadrant number 2. It's the second quadrant you'd hit. Then you'd hit the reflex angles, you'd be in the 3rd quadrant, and then the 4th quadrant. That's why they numbered them counterclockwise. That a lot of people didn't know that. That's the way it is. Okay, so what I like to do, go to your, 3rd graph, 4th graph, whatever you're on. Move to a new graph. So move to a new grid. Now you got your angles kind of laid. Okay, same thing again. Draw, so you should make a new graph, 2nd graph, I guess, if you have new paper on here, or 4th graph. Draw your initial side again. X-axis going along it. What I like to do is draw a ray that is going straight up from there. Straight up. That's your terminal side. Okay, it's wherever you ended. So on all those examples we've done up to this point, the terminal side is always where you end. So it's your terminal side or terminal ray. My terminal ray just happens to be along the y-axis, right where I stop. So we are opening up this direction, right? You don't need to draw the arrow, that's the way we're going, okay? Now we're in between the 2 quadrants, correct? We're in between 1 and 2. This type of angle has a name. It's called a quadrantal angle. It's an angle that falls right in between. So 90 happens to be like one of the first quadrantal angles. But here's the thing. The question I always got, and people have the wrong misconception, is why do they always put a box on a 90-degree angle? Why do they, like when they're drawing a 90-degree angle, why do they put that little box right there? And the misconception I always have is, oh, it's a square. Squares, it's a square. Squares can fit right there. It's flush. Those right there, they have 90-degree angles. It's not because of that. It's actually because of the picture you're looking at right now on your graph. When you draw an angle on the Cartesian coordinate plane, guess what's in the corner here? The first 1x1 box. That's where it comes from. That's actually why that box is sitting there. It's because the graph paper has a literal box sitting there. It's perfect. It fits. That's where it comes from. Most people think it's because it's square. No, it's because of this. It's actually how you draw it on the coordinate plane. Little things like that in math, a lot of people don't know. Don't see it. Okay, now, what we're going to do today is we're going to practice drawing, measuring, and all that good stuff. But there's a couple parts we have to talk about. So initial side is where you start. The vertex in this case is always on the origin. That's where the vertex will be. And your terminal side is wherever you end. Wherever you stop. Those are for positive angles. If we went negative angles, which we'll see later, you go down. You open up downwards. Okay, questions, comments at all about the process for drawing? Now, why I bring this up? It's because when we draw angles, we're not going to do it on grid paper anymore, right? Because we don't have grid paper when we work on homework. We're going to be drawing this on nothing, like this, just plain white paper. I still want you to draw your angles in what they call, quote-unquote, standard position. So everyone in this room will draw the exact same picture. They're not going to face different directions, up, down, right, left. No. When you start drawing angles, You will always start your terminal side like this. So if you go to your notebook paper, you will always open up to the right as your initial side. So a straight line across. Use the blue lines on your paper if you need to. This is standard position. This will guarantee everyone in this room will draw the same picture. It's like you're drawing along the x-axis again. And then you're going to open up counterclockwise, open up this direction until you hit your terminal side wherever you want to end, and that's where your terminal side will be. So initial and terminal. Back when we label this. You don't need to label them every time. I'm just going to label them. So here's your initial, here's your terminal. Just get used to it. And the vertex is right where the dot is your vertex. All right, I need 3 letters, please. Can somebody give me 3 letters? Nay, what do you got?
S.
S? Give me another one. What? R. Give me another one.
L.
L. Okay. We're going to name our angle. Now, this is a simple picture. So the book says you can do a single letter system. So this is notation again. So notation when you're writing. You can use the single letter system. You can go angle R. That's your vertex. I don't like that. I actually despise that. I always like to use the 3 letter system or the number system. So that's notation. Now notice, I always draw a little mock picture of the angle in front, and then you have the letter. And the mock picture you draw in front of your letters do not even have to look like the angle. Even the angles of 2s, you can just draw that symbol. It's an angle symbol, angle R. But I like the 3 letter system. So how would I write my 3 letters? What do you remember from Friday? Please, Alex.
Doesn't the R
Say it again?
is the R first?
No, not first. Has to be in the middle. R has to be in the middle. So then it doesn't matter the order you write, as long as R is in the middle, so we can go SRL or LRS. Yep. So it has to be in the middle, no matter how you write it. That's the way I prefer it. Now the book says you can do the single letter if it's a simple picture. This is an easy picture, there's nothing going off it, it's just one angle, whatever it is. Typically they always talk about the smaller angle, not the outside. The outside's kind of a, it's reflex, but I'm talking about the smaller angle on the inside. If they numbered it, so on your picture, let's number it angle number, let's go angle number 1. You can call it angle number 1, if you will. That is not a degree. Obviously, it's not degrees if you happen to know how to use your protractor at all. All right, the goal today is we're going to learn how to measure. We're going to learn how to measure first. So does everyone have an angle drawn on their paper? What we're probably going to need to do to guarantee this, now I know that a lot of you are just kind of drawing freehand. You can extend the walls further. So if your angle's like really tiny, like you're that person that draws really small angles, extend the walls. Make these a little bit further. Use a dash line. Use your straight edge, or I guess the corner of your book, the side of your book, or use the protractor. It's got that flat wall. Use that. Extend these walls further. Use straight lines. Don't just freehand draw it. Actually, use the corner of that protractor. And we're going to measure this angle. We're going to find the measure of it. So you're going to take it and you're going to put it right on top of it. Now, let's see if I actually have. Look at this old thing. Yep, this is mine. Old, it's gonna work. Okay. So you're gonna take your protractor, now I know yours is a big plasticky thingy piece. Okay. It's basically the same concept. You have all your numbers, there's 2 sets of numbers, perfect, whatever you got. For you guys, you have a dot at the bottom where everything's gonna go into. I have an arrow, whatever, I have an arrow. Okay, what I'd like you to do, put your dot that's right in the middle of that protractor right on top of R, the picture you have drawn. And you're gonna put that dot right on top of R. Now, this is the part that always gets people. So you have your dot on the R. And try to make it perfect. You're gonna line up the bottom line, I think for in yours you have a really solid black line, correct? Like a dark line. Line it up with the initial wall. So line it up perfectly. So like 0 or 180 is right on top of that. Once you have that, we're gonna count up. So we're actually using, in my case, I'm using an inner track. Is the inner track for you guys, does it start at 0?
Yeah.
The 0 is the inside? Okay. We're gonna count up. So you got your R lined up at your dot, you have the line going across that initial side, 10, or 0, 10, 20, 30, 40, 50. I'm almost to 60 on mine, almost to 60. It's not quite to 60, so it's actually in the 50s still. Remember, you're counting up. So if I don't get to 60, I'm at 50 still. So mine is 59. So on the inside of my angle, I'm gonna write a big 59, and I'm gonna put a little degree symbol on it. Now, for yours, you need to measure yours. You need to figure out what number you landed. Remember, use the inner track, whatever your numbers are. Let me draw a mock picture of this. So you have your compass is here, you know, my angle is right here. Maybe it's doing this. This is what your picture kind of looks like. Where this is, again, I'm using the inner track. This is 0, and then you have the 10, 20, 30, 40. But you didn't get quite to 50. 50's up here. So you're kind of in that weird range where you're kind of looking. Maybe it's 44 degrees. I don't know. You got to figure out where the angle is going. I want to see what number you have. So put your protractor down your paper. I'm going to walk around and check. Where's that? 45 is pretty good. 46. Yeah. That's right past 35. Okay. Let's see, 55-ish? Not 55. There's more counting. 0, 10, 20, 30, 40, 45. You didn't get quite to 50, so 45. Yeah, see? A little thick. Okay. Saying 43-ish? Let's see. 33. 0, 10, 20, 30, you're just past 30. So 33, not 43. You're not past 40. So below a 6 here. Let's get going here. Let me measure 56. So, let's see. Yeah, we're going past 50. Okay, good. 59, 6 degrees. Past 50, almost 60, yeah, I agree with that. You're saying what, 64 or 54? 64. 54. Boom. Yeah, almost agree with that. Right on. 40 degrees is exactly. Yeah, I agree with that. 40. Okay, good. Let's see, what number you said? 45? Yeah, that's good. 60, that's good. And 62. Yeah, you went right past 60. That's good.
What are y'all saying? Yeah, okay.
49. Yeah, 47. Yeah, I mean, just short of 50. Okay, good. All right, did I check everybody's? Did I miss anyone? Apologies if I did. Okay, I think I got everyone. Okay, the most common mistake people make is like what I'm saying here. You're counting up, you're not quite to 50, but you're counting up and you just see the 50 and you're like, oh, that's 55. When you're still counting up. So if I just went past 40, I'm in the 40s still. Remember that, count up. You figure out where you're at. You're not quite to 50. You're counting up, you have to be past 50, be in the 55s or 60s. Right, and I want it to be accurate. If you're within 1 degree, I give it to you. If it's off by 2 or 3, I count it wrong. And when on tests and homework, I put my compass right on the paper, like yours. I put it on the paper and I remeasure it to make sure it's exact. Okay, so my angle's 59 degrees, that's the measure. Now, how you write this is something new. We didn't talk about this on Monday. That if you want to write the measure down of an angle, do this. Put a little M out front, so the measure of your angle number 1, or whatever angle you called it, measure of angle SRL, you put a little M, put an equal sign after it, you now put the number of what your angle was. I know I saw like a 121, I saw a 67 or 47, I saw 30s and 40s and 45s and other numbers, but whatever numbers, mine's 59. I'm going to put a 59 degree here. On that prime over here, right, whatever this angle is, let's call this angle B. Fine, angle B, the measure of it is 44, let's say. I have no idea, whatever yours is. That's what the little M means. I always get a lot of questions. Ward, why does it put a little M? It wants you to measure it. Go figure out what the number is on the protractor. Now, other than, I think everyone in this room did a small angle, if there was only one, that did an obtuse angle, because again, it didn't matter what type of angle you draw. But if you had to be obtuse, let's draw an obtuse now. Wheeler, draw an acute this time, since you did a bigger angle last time. So, okay, let's draw an obtuse angle on your paper. You do not need to put your protractor down, just move your protractor out of the way. Draw an angle, but I want it clearly obtuse, past 90 degrees. So we're gonna practice drawing that. So clearly obtuse. Let's label this angle, let's call it X, Y, and Z. I'm not gonna get too creative here. X, Y, and Z. Y is the vertex. An obtuse angle. I'm gonna walk around just to check that you have an obtuse angle drawn. So it should be a very quick check. Oh, you went real big, didn't you? Yep, real big. Yep. Oh yeah, just checking we got obtuse going. Just, it should be common sense when I first take a look at it. Oh yeah, these just have to be bigger. Okay, good. All right, and make sure you draw them this time. Okay, so now that you have your angles drawn, put your protractor right down on top of it again. So you're gonna line up the dot in the middle right on your vertex Y, and you gotta line up that first wall, that bottom black line right here. So your compass should be going kind of like this. There's where your compass should be sitting, right? You're lining it up perfect so that you can count up. You still have to start with the initial wall. That's why I've been trying to label this the whole time. A lot of people make mistakes here. You still have to start with the initial side as 0, and you're counting up. So you're still using the inner track numbers, correct? But we're counting up. So we're going to start at 0 degrees is over here, 10, 20, 30, 40, blah, 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 till you get to 90. We're past 90. We're past 90. 90 was straight up and down. But we're going past it, so now we're 100, 110, 120, whatever this number is. In fact, I need to put my protractor down so I can actually see. I don't even know what mine is. I'm going to line it up. Line up that bottom wall. I'm going to go 0 time up to 90, past 100, 110, 120. I'm just past 120. In fact, mine's about 125. I'm not quite to 130 yet. So 125. That's my number. 125 degrees. I have no idea what yours is. I want you to measure it right now. Within 1 degree of it. I will walk around the room. I'm going to check to see what you have. Let's see. Yeah, you're almost just past 140. So 141. Yeah, you're close. Yeah, just shy of 130, isn't it? Yeah. I was going to say yours is pretty big. 176, yeah, you're almost right on it because it's just past the 175 mark. Let's see. This is kind of big, 168. Yeah, because you were quite 170. That's good. And 148. Yeah, almost to 150, not quite, just shy. That was good. All right. 120. Let's see. Yeah, you're about as close as you can get to 120 though. 145. I'll stop. Actually, make it to 32. Yeah, so we get 20 here. Okay, second. 142. Yeah, that's 146. 141. Yeah, 142, 141. 146. Yeah, you just ask 145. 125. Yeah, almost right on. Okay. 146. Yeah. 148. Okay. All right. Okay. Now, that was fine. Danny. You guys are drawing angles. You're measuring them. It looks like the accuracy is there. We're still getting little problems every now and then. You know, going the wrong side of the bar. That's fine. We're getting there. All right. Now, here's the question. I want you to draw a 81-degree angle. Perfect 81. Now we have a problem. Now it's not just a freehand draw. Now we have to draw it accurately, right? 81 degrees. So to do that, what do we have to start with? Say it. Well, we gotta have a protractor in hand. Good. What else? Straight line. You have to draw the initial side. Your first line that you're drawing on your paper better look like this one. It better be horizontal to you, going to your right. Because everyone in this room has to draw it in what they call standard position. It has to go to your right, like that. If you didn't start like that, we have a problem. So now, here's how it's going to work. This is my best way to show you how to draw an 81-degree angle. Once you have your initial side, take your protractor, put it down your paper. Now I know your protractors are really big, but line it up so your dot's there, you have your 0 or whatever that line, you know, going across. We're still using the inner track numbers. You're going to count up to 81, so you got to go past 80. So you're going to go 10, 20, 30, 40. When you get past 80, all you have to do is move your protractor and make the mark. Notice I didn't move my hand. I didn't move my hand. All I did was just move the protractor out of the way. I found where 81 was. I moved out of the way and I made my mark. That's the hardest part, is you got to figure out where 81 is, move the protractor without moving your paper, make your little mark, and then draw your final line straight up there. Your final line should go from your vertex straight up to that point you just made. And just use one of your straight walls, you know, on that protractor to do it, or use your line notebook paper or something where you can actually draw a really accurate straight line. 81 degrees. It should look almost up and down. Now, why I had you draw 81. This is kind of the threshold that after 81, you know, 82, 83, in that ballpark, somewhere after that, the human eye can't differentiate if it's perfectly right or not. It's like after the 81 and 82 mark. It just kind of looks like it's an L shape. Some people are really acute to that. They can see it's not L. They can see, like mine, I can see it. But if I went past 81, I went to 83 or 4 or 5. It'll look like 90. The human eye can't perceive that. You have to be able to measure super accurately. Have your neighbor take a look at yours. You know, double check. Does it look like 81? It should look like the picture you had drawn. If it doesn't look like 81, we have a problem. Now, if it's on the wrong side of 80, maybe you want to measure it. We need to be accurate, like really accurate. Okay. Let's label this angle. Let's call this angle, let's call this one A, B, and C. I'm going to use those letters today. So A, B, bless you, and C, A, B, C. So how do I write it in notation to say that it's equal to 81? How do I write it? We already got it.
M equals A, B, C
Good.
equals 81.
Good. That's what I want. There's other ways you could write it. You could wrote M, angle B equals 81. Because it was a very simple picture. You could have wrote the letters backwards. CBA is 81. But the vertex had to be your middle letter. Those are all the same to me. I like the 3-letter system. You'll start to see why when we start mixing the problems together. Okay, now again, we're using a protractor to measure. That's accurate. Well, if you didn't have the protractor, that'd be a completely different story. Trying to draw angles accurately without a protractor. There is rules for it. We have constructions that we can actually draw angles with just the compass and the straight edge. It's really accurate. That's what we're going to try to practice tomorrow. last thing I want to cover. So you can put your protractors away for right now. Put them away. Just have your notes. You won't need your graph paper yet today. Hopefully you have your graph paper with you. Put your name on it if you haven't already. I know some of you just had new graph paper today. But you need your notes now. We have one more note to take and then we're done for the day. One more note. Last note of the day. Adjacent angles. It's not a classification of angles like by degrees. An adjacent angle can be any type of angle, doesn't matter the size, 20 degrees, 180 degrees, it really doesn't matter. What adjacent angles are two angles. There are two angles that share a common endpoint and a common ray. There are two angles that share a common endpoint and a common ray. Now, that definition is kind of vague. There is a certain stipulation for two angles to be adjacent to each other. But all you do is not accurate, you don't need your protractor or anything like that. Draw an angle in standard position like such. Standard position. Just make it a cube, doesn't really matter. So you have your angle, standard position, right? Horizontally open up, you draw your terminal side. Now, I want you to, from here, from this same vertex, draw another ray going somewhere else, going off of it. So now what you have is you have potential to see two different angles. There's actually three there. There's two angles that are side by side, correct? They're sharing a common vertex. This is the vertex they're sharing. And they have that common ray in the middle. This is the common ray between them. These two angles are adjacent to each other. They're side by side. They're literally being shared between each other. You could put them together and make one big angle. They're not overlapping. What I mean by overlap is something like this. You have one angle and then you have another angle doing this situation. That doesn't work. You have the big angle here and you have the small angle. That's not adjacent. Adjacent is when you're actually talking about the two separate angles side by side to each other. They're literally side by side, so you can add them together. Okay, this is overlapping. You can kind of see it. They're very particular, because they say common ray, but the common ray has to be in the middle. It has to be between them, not on one of the far edges. All right. What we're going to learn on, I guess, Tuesday this week is how to add angles together, how to measure and do that. Question?
Wasn't the ray the line you do like straight across? So it has to be in between.
It has to be in between. The common ray has to be in the middle of them, not on one of the far edges. Yeah. So that's what we're going to look at tomorrow. I know it's a simple word, but the drawing of it is a little more important than you think it is. Well, we're going to focus on that tomorrow. We only have about a minute left here. Remember, we have homework due today. If you haven't already, that's page 30. Make sure you're getting that turned in. If you haven't already, I'll try to get those graded tonight and hopefully hand it back. So, if you brought a calculator for me, make sure you get it returned. If you have a protractor, keep it in your book, keep it in your notes. You don't lose it.
Pictures. I'm bored. I'm got nothing to do. Don't think it's recording. I don't want to do hills.
Oh, wow. Oh, it's still funny word terms.
Roger Bacon, what a man.
Hey, Georgie. Recording, you idiots.
Roger Bacon.
You know when it's recording, then it's
It's face tracking you.
Huh?
It's face tracking you.
Oh, is it actually the signal? Yeah, but it's not actually recording.
So my class meeting finished after. So we're doing that today. You can do it again.
What are you guys doing? Just looking at my camera.
Hello.